Okay, so today we'll solve GET 2021 question. This is a question from real analysis. This is question number 36. Saying that let fn be a sequence of function is given. It's defined by fnx equals to nx cube into e to the power minus x for n belongs to natural number. And then the two statements are given. Saying that fn is equicontinuous, means this family is equicontinuous in the interval 0 to 10, it's compact interval. And statement q is saying that summation n equals to 1 to infinity fn does not converge uniformly on 0 to 10. Okay, so then four options are given, that which one is correct or which one is false, you have to check. So this is the question. In order to solve this is the NPTEL reference. This you can check. Okay, now let's start to solve this one. So let us first recall what is the definition of equicontinuous. Let me recall the definition. Equicontinuity. Okay. So first let this is scripted be a collection of real valued continuous function. Be a collection of real valued continuous function. On a, suppose let's do it for one metric space, you can do it for R or because they are metric spaces. On a metric space, X, let's say. Now what is the definition? So F is a collection. So say equicontinuity is saying that when means Fn is a collection of continuous, it has a collection of continuous function. When saying that when these all collections are means, yeah, it is saying that this it taking over the continuity of this collection. So we say F is equicontinuous if for given epsilon greater than 0 there exists a delta greater than 0 such that whenever x and y belongs to x satisfy such the distance of xy is less than delta, we have mod of fx minus fy is less than epsilon, and this is true for all f in this collection. So what it is saying, so given any epsilon greater than 0 there is a delta such that for all xy means, so this delta does not depend on xy, such that whenever x and y are very close means d of x comma y is less than delta, we have mod of fx minus fy is less than epsilon, means fx and fy are close. So what is so note that what is the difference. So there are three type of continuity, first you learn that pointwise continuity. What it is saying that for a fixed an x and given any epsilon there is a delta which may depend on this x, right? So this is the pointwise continuity. Therefore pointwise continuity delta may depend on x. And now then later come that uniform continuity. Then it is saying that in the interval or wherever you are doing, so given any epsilon greater than you, there is a delta, so that it should not depend on the point x, it should hold for all x, you get a single delta, right? So this is the uniform continuity. And here what is saying that equicontinuous? It is saying that for epsilon greater than 0 and f is a collection is given, means many functions are there. It's saying that you get a delta which should not depend on x and also f, means it should be independent on x and f, means this delta should work for all x and for all f in the collection, right? So this is the mm, difference between pointwise continuity, uniform continuity and equicontinuity, right? Now what we have to find? We have to find that this family is equicontinuous on 0 to 10 or not. Okay. So for that I will use one result that you can prove easily. I think I will give some idea. So what is the result? It is saying that if fn converges to f, so this is a sequence of function, converges to f. So we are assuming here, let fn be a continuous function. Let us start with this. Let fn be a sequence of continuous function if fn converges to f uniformly. Then fn is equicontinuous, means this family, or let's say let we are doing it for let x be a compact matrix space. And this is on x. Right. So what is saying that if x be a continuous function and fn be a sequence of continuous functions, a compact matrix space, let x be a compact matrix space and fn be a sequence of continuous functions on x, then if fn converges to f uniformly, so what is there mean fn converges to f uniformly? Means in this for all x such that we will get a natural number n such that fn minus f should be small for all n which is bigger than this capital N and for all x, right? So this is the meaning fn converges to f uniformly. Then saying that if this happen, then you can say that this collection means this sequence of function is equicontinuous on x, right? Okay, so for this let me give the hint how to you can prove, or you can prove it also. So use two things that, or just use the definition of first hint number one. Use definition of uniform convergence. So means here you have to say that for suppose for all y it's saying that an fn minus fny minus fy is less than epsilon, so that for all small n greater than some capital N, right? So basically Here you will use this one. So that for all n, for all y, and for all n bigger than some capital N, it will there is some capital, which will imply mod of fny minus fy is less than epsilon, right? So this one use this, and second use that because here fn are sequence of continuous function. If they converges uniformly, then f will be continuous, right? This is the standard result. So f is continuous and this is compact matrix space, so f will be uniform continuous. So use the uniform continuity of f, right? So what is this meaning? Means that for some delta dash bigger than 0, such that for all y and all x belongs to x, such that if d of xy is less than delta dash, which implies mod of fx minus fy is less than epsilon. So let me call this by epsilon by 3 technique. Now let me write epsilon here, epsilon, right? So use these two, then use these two, and just what you have to prove that fn minus. So to prove, so these are the two hints. And a sketch of the proof. So what you have to prove? Note you have to prove that what is the definition of equicontinuity. To prove that given epsilon greater than 0, there exists delta such that whenever xy belongs to x, so when distance of xy is less than delta, fx minus fy is less than epsilon. So given epsilon greater than 0, there exists a delta bigger than 0 such that for all xy in x, so whenever this d of xy is less than delta, which will imply fn x minus fny is less than epsilon, right? For all fn, this sequence, right? So this you have to prove. So here what you will do, then just write this one, fn minus fnx minus fny. How you will write this one? You will just use write this way, fnx minus fx plus fx minus fy plus fy minus fnx. So what I have done, I have just add and subtract this one and add and subtract this one. Now what I will do, I will use the triangle inequality. So fnx minus fx plus fx minus fy plus mod of fy minus fny, right? Now note the by hint 1, if you use this, sorry, if you use this one, you can make the first term fny fnx minus this to be less than epsilon. So I will take epsilon by 3, and the second term by the uniform continuity f, you can make this to be less than epsilon whenever d of xy is less than delta dash. And the third term similar to the first term, right? So you can take epsilon by 3 plus epsilon by 3 plus epsilon by 3, and because of the second term, what you will get, this is true when xy are less than delta dash, right? So whenever d of xy is less than delta dash, right, for some delta dash. And for the first two term, what you will get from these two term, you will get for all n bigger than some natural number, and for all n bigger than some natural number or equal to, right? So you will get this for all n bigger than natural number and dxy less than delta. But what you have to show, this is less than epsilon for all fn, right? Here n is all natural number. So you have only remain with finitely many. And so for finitely many, what you will do, because you know each fn's are continuous, so for f1 you will get now for, so you have only remain with this one f1 f2 up to dot 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 fn minus 1. So what you will get some, because f1, so you need f1 minus f1x minus f1y to be less than epsilon, so get some, because they are continuous, delta 1 such that d of xy whenever is less than delta y, you will get f1x minus f1y is less than epsilon, right? So similarly for, you will get some n minus 1 delta n minus 1 such that whenever d of xy is less than delta 1, and note that they are uniformly continuous each fn, right, because x is compact matrix space. You will get fn minus 1 x minus f of n minus 1 y, this is less than epsilon, right? Now what you will get, what you will do, so now you will take delta to be minimum of all this, minimum of delta 1 delta 2 up to dot dot delta n minus 1 and delta dash. Then for this delta, then for this delta, we have, so this is for n bigger than capital and this is for up to n minus 1, fnx minus fny is less than epsilon whenever d of xy is less than delta and for all fn, right? So this is the proof basically for this statement. Okay, so this result, now we'll use this result to prove our, so what we have to prove, that fn is equicontinuous on 0 1 0 to 10. So now here what it is given, fn from 0 to 10 to r, it's given by fnx to be n x cube e to the power minus nx. So we'll show that these fn's are uniformly convergent to 0, right? So how you will show that? So note e to the power nx, this you can write, right? 1 plus nx plus n square x square by factorial 2 plus n cube x cube by factorial 3 plus dot dot dot. Now let's, here we only need x greater than 0. So for x greater than 0, what you can write, that e to the power nx, because all these are positive, so e to the power nx is bigger than n cube x cube by 3 factorial, right? So which means that n x cube, so this is bigger than or equals to n x cube, or it will be strictly bigger than, right? E to the power minus x, take to be this side, you can write this to be less than 3 factorial by n square, right? So if you simplify, you will get this one, and this is the fnx, right? So what we have to show, so first note that, so this is the, you will use this estimate. First note, for each x, means this is pointwise convergence, fn's x goes to 0, right? Because if you fix x e to the power minus nx, this is goes to 0, e to the power minus s, n by e to the power n will goes to 0. So for each x fixed, this goes to 0. And for, so therefore you have to show that this is uniformly convergent to 0, means fnx minus 0. So this is basically fnx, and this is n x cube e to the power minus x nx, and what we have got, that n x cube e to the power minus is less than 3 factorial by n square. So this is less than 3 factorial by n square. Note that this we can make, this is x independent, right? So so this does not depend on x, and this we can make so sorry, this is n square. So given epsilon greater than 0, there exists capital N such that you can, because 1 by n square goes to 0, you can always make 3 factorial by n square less than epsilon for all n bigger than some capital. So then fnx minus 0 is also less than epsilon for all n bigger than capital N. So, and this does not depend on x, right? This n, capital N, because it's only independent of x right hand side. So which implies fn converges to 0 uniformly. On, because we only need 0 to 10, so this. So you've got that fn converges to 0 uniformly on 0 to 10. Now what is this theorem is saying? And we have also compact matrix 0 from, because 0 to 10 is compact matrix. So then by this result, we can say that fn's are equicontinuous. So therefore, by the above result, fn is equicontinuous. Okay, so you have done the first one on 0 to 10. And what is the next one? It's saying that summation fn does not converge uniformly on 0 to 10. And this is also easy. Just here use the, for the next one, use the Oyster's M test. Now let me write. What is Oyster's M test? So it is again for sequence of functions. Suppose fn is a sequence of functions on, suppose x, such that there exists a positive sequence of real number sequence of positive real number, right? Sequence of positive real number, let's say mn, such that condition 1 it is that fn x is less than equals to mn for all n belongs to natural number and x belongs to x. Condition 2 is saying that the series of mn should converge. Then the series of function converges absolutely and uniformly on x, right? So here we have to find that summation fn is uniformly convergent or not. So here, so you have to find a mn, right, positive sequence. Here we have fn x, what we have, n x cube e to the power minus x for x between 0 to 10. And what estimate we have, because we have to estimate this one, so what we have got, right, because fn x we have shown this to be 3 factorial by n square, 3 factorial by n square as this one, and we know because 3 factorial is constant, just 1 by n square, sorry these are n square, always I'm writing n factorial, this converges, right? So therefore by Oyster's M test so this is here fn, right? Because this series converges, so the by Oyster's M test summation fn x converges uniformly on 0 to 10. Now let's look. So we have done this one. Which option is correct then? both P and Q are true. So P is true, but it is saying that summation Fn does not converges uniformly. So Q is false. So therefore option number B is correct. P is true and Q is false. Okay.